Hi, now I'm going to perform the linear discriminant analysis. So you should refer to my previous video on principal component analysis because this is the continuation of the overall exercise. Okay, now we go again. Look at this data, right? We have this data on concentrations of the different elements in stingless bee honey specimens collected from various parts of Peninsular Malaysia. So now what we are going to do, we are going to open the SPSS. Okay, we are going to import the data from Excel into the IBM SPSS environment. To do that, you click Data, File, you click File. Okay, you go to Open Data, right? So find the data where the Excel file is actually located. It's actually in my Tugas Rasmi. Okay, in my lecture note, right? Forensic chemistry, statistic for forensic science, exercise. Okay, change to Excel. Okay, then this is the data. This is the file, trace elements in honey. Double click, right? So you'll be prompted with this window. So we are going to focus only on the rainy season data. So you change this to rainy and then you click OK. So these are the data, okay, from the Excel. We have the region, we have the elements. We have to add one more variable here, the what we call the region. These are the different districts, okay. Right click, insert variable, go to data view, okay, label this as region. Okay, then you can go to your values. So we label one as east, two as north, three as central, and four as southern, south. Okay, so we are good now. We already labeled that. Okay, okay. Then you go to data view. Here you have to label the data. So 1, 3, you have to label carefully. 4, okay. Make sure you label everything. Okay. Okay, we are done. Now we go to analyze. We go to classify. Okay, go to discriminant. Okay, transfer the region into grouping variable. Define it as 1 minimum and 4 maximum, as we already assigned that value. So we transfer all the different elements into independence, right? Click statistic, make sure that you check Fisher, right? Continue. Then click classify. Okay, make sure that you click, this is very important, leave one out of classification because this is the validation that we are going to interpret later. So click leave one out classification and combine groups. Okay, continue, save. We are going to save the discriminant score in this worksheet. So click discriminant scores, continue, and then we are good. Click OK. Right, these are the outputs. You can see that 47 were actually valid, 1 excluded because we leave 1, okay, for validation, right? That's fine. Now you can go to yeah, this classification results. Okay, this is very important. This is where we are going to report our correct classification percentage. So if we compute all the 48, the correct classification will be 100%. But this is not the one, because we purposely choose to leave one out of for validation purpose. So when we leave out one and we tested the one against the model, the correct classification is 95.7%, and this is very much acceptable. So because the accepted value will be around 80 to 99%, 90 to 99%. So 95.7% is acceptable. You can copy this table later on and put in your MS Word. You just click and then copy, and then you paste the normal way and import that into your MS Word. Okay, now what I want to do is I want to look at the what we call discriminant factor calculated. So now you can see this one, this two, this three. Okay, so these are the values that we have to copy and transfer into our Minitab environment. So click, right click, copy, and then you go to your Minitab, right? You click File, New Worksheet, right? Okay, so and then place it here. Okay, and then paste cells. Okay, so we label this as discriminant factor 1, discriminant factor 2, discriminant factor 3. Okay, so and then we have here district, and then we have region. Okay, go to your IBM Specialized worksheet again, right? We are going to copy that, right? Okay, so we are going to copy region, district and region. Right click, okay, copy. Then you go to your Minitab, okay, and paste. Right, so we are good now. So we have the discriminant factor. We have all the things that we require. Okay, now we are going to do the analysis. We already have the correct classification rate, everything, right? So now go to graph, you go to 3D scatter plot. Okay, simple again, click OK. Now we have to remove all the previously entered variables. Okay, now for x variable, I'll put discriminant factor 1. For y variable, I'll put discriminant factor 2. And for z variable, I will put discriminant factor 3. Okay, and then click OK. Right, so this is the scatter plot. Okay, generally you can see two separate groups. Okay, but to see better, you place your cursor and click any of this on any of the dot, right click, and then edit symbols. Right, so you go to group again. Okay, we are interested to know the region. Okay, so we click region, select, transfer that. Okay, now you have the region. Okay, if you notice, this is one error. Okay, 33 is actually wrongly entered in as IBM SPSS. You have to correct this later. It's supposed to be 3, right? It's not 33. So I was wrong when I entered the data. So you can look again at the data. There is one place that I put 33, I think. So, okay, that one is actually the one that we leave out. Okay, right. And okay, now we go to, okay, we can rotate this. As you can see, right, the classification is much better than that of PCA. You can see one cluster here, one cluster here, here, and here. And the one that we tested, we leave one sample out, is actually clustered around the central sample. So this is actually quite good. So the percentage of correct classification is 95.7%. That's fantastic. So that's how you perform linear discriminant analysis using Minitab by using IBM SPSS as assistance to calculate the discriminant factor. Right? Thank you.